Flash is advancing the future of laser-based manufacturing by enabling flexible, multi-process, and energy-efficient production systems for European industry. We brought together leading European partners to address key manufacturing challenges: limited flexibility, high energy consumption, and complex process integration. The project delivered important technological outcomes, including multi-laser integration, adaptive beam shaping, and real-time digital process control. Therefore, we asked some of our partners about the key outcomes, innovations, and impact of the technologies. What is the Flash project about, and what is its impact within the European framework?
Flash project is a 3 years project funded by the European Commission, and the main target is to combine 3 different technologies in a single machine, thanks also to the combination of 3 different laser sources.
Based on ATS progress in training and validating the artificial intelligence and machine learning procedures, which capability of the autonomous system stands out the most?
For ATS, success would be the successful implementation of a co-pilot type facility for this project, such that with a meaningful human question, we can provide a human-readable output that can provide real diagnostic capability to potentially untrained operators of this kind of equipment.
What was the key lesson in integrating the hybrid acoustic optical sensors, and how can this in-process monitoring support the yield target?
So at IMAN, we developed a new monitoring solution that combine both acoustic and optical sensors within the Flash project. And I have to say, we did not expect that the combination of both origin of the sensors would be so difficult, because they don't cover the same thing either in terms of range or anything. And to synchronize them, the data fusion was quite challenging. But we're happy with the results. We now have a fast monitoring solution that allows us to monitor and to understand a bit better the process. And as we all know, in order to reach a good market and a good yield and a good throughput, it's important to understand what's going on within the machine. And I think with this new sensor, we can help to achieve this by understanding what's happening, and mostly when things are not happening the way they should. So yeah, we're quite happy with the Flash results and what we achieved within it.
Based on the M30 database, can you highlight a Flash use case that showed significant improvements over conventional manufacturing?
One of the key objectives of this Flash project is to seek how we can develop a flexible system, or how we can develop a single system which can be used for a range of manufacturing applications or processes. And one example that I want to highlight is on hairpin welding. And we have successfully showed that through this project that we can demonstrate these things. For example, we started with a continuous wave single mode fiber laser for cutting process. So first we cut the strip using a nozzle based beam delivery, and then the second process is the stripping of those enamel coatings. So where we modified, or we changed the system from nozzle based to galvo based on the same machine to demonstrate or to remove the coating. And then for cleaning process, we have been using nanosecond laser. As you can see from the Flash project concept, it uses various types of lasers, CW laser and nanosecond laser, and we use the nanosecond laser specifically for cleaning of or surface modification of that strips. And then finally we come to welding. Again, we use the CW laser for welding.
Flash results demonstrate clear benefits for industry: reduced production time, lower energy consumption, increased process versatility, and strong potential for industrial adoption. Equally important, the project generated valuable lessons learned on system integration, digitalization, and collaborative innovation. By now, Flash has delivered validated results that support the transition towards more flexible and digitally driven manufacturing. Ready to know more about our project and future developments? Join us, and feel free to access our website. This project is funded by the European Commission.